Hi, Assalamualaikum everyone. My name is Ahmad Bakir bin Azman, and meet my teammates Azim Hazmi bin Hasmariza, Ammar Faris bin Zavani, and Amir bin Zalkafli.
We are from 2G and we will be presenting techniques of differentiation.
Everyone, my name is Omar. Today I'm going to answer the first question, which is explaining what is differentiation and technique in differentiation.
Well, we start with what is differentiation. Differentiation is simply a measure of the instantaneous rate of change. It is a concept of real variable that measures its sensitivity to change in value output with respect to the change in its argument. It is used to measure the rate of change of a function with respect to its variable. For example, in physics, if you have a function that gives the position of an object over time, then its derivative gives the object's velocity.
Okay, now I'm going to explain techniques of differentiation. First technique, we have product rule, which is we can use the product rule when you are differentiating the product of two functions. For the function fx equals u times v, when we differentiate it, the formula is uv prime plus du prime. For example, fx equals x squared times sin x. First, you have to identify which is u prime, d, and d prime. So we let u equal x squared, u prime equals to 2x, d equals sin x, and d prime equals to cos x. Then we apply the product rule, which is f prime x equals uv prime plus du prime. Applying the rule, we got 2x times sin x plus x squared times cos x. That is the final answer. For the next technique, we have quotient rule. With this quotient rule, when differentiating a function, there is a fraction, one function divided by another. So the function is fx equals u over v, and the formula is f equals to uv prime minus du prime over d squared. So for example, fx equals x squared over cos x. First, you have to identify the numerator and denominator. So clearly we can see the numerator is x squared and the denominator is cos x. So the numerator is u, which is x squared, and the denominator is cos x, which is v. Now differentiate both of them, which is u prime equals to 2x and v prime equals to negative sin x. And then we apply quotient rule, and we got f prime x equals to 2x times cos x minus x squared times negative sin x over cos x squared. And remember to not expand the v squared. And then we simplify, and we have the result of 2x cos x plus x squared sin x over cos x squared. On to the next technique. It is chain rule. We use chain rule when there is a function inside another function. It's like a composite function. The function is y equals to f gx, and we differentiate it, becomes f prime gx times gx. So for example, gx equals to x5 minus 6x squared plus 2 to the power of 5. Right? When we differentiate it, we bring the derivative, which is 5 to the front, and then we differentiate x5 to 5x to the power of 4, then differentiate 6x squared to 12x, and then we copy the original function and then to the power of 4, and that is the final answer.
Hi everyone, my name is Amir bin Zalkafli, and today I will be explaining how to solve question 2, which asks us to find the derivative of two functions. In other words, we will be asked to figure out how each function is changing at any point. Okay, let's start with the part A. The function we are asked to differentiate is a product of two parts, 2x to the power of 4 and exponent to the power of 6x. To differentiate this, we use the product rules. The derivative of 2x to the power of 4 is 8x cubed. Meanwhile, the derivative of exponent to the power of 6x is 6 times exponent to the 6x. Using the chain rule, we are able to get the derivative of exponent. Putting it all together, the final derivative is exponent to the power of 6x multiplied by the sum of 8x cubed and 12x to the power of 4. Okay, now on to the part B. B is a chain rule problem because we have a logarithm with a power. We start by bringing down the exponent 5, then keep the inside as it is, and subtract 1 from the exponent to get the new power of 4. Then, we multiply by the derivative of the inside, which is ln of 8x minus 8. The derivative of that is 8 divided by 8x minus 8. We also can multiply the constant with 5, so that we can get the final answer, that is 14 times ln of 8x minus 8, all raised to the power of 4, divided by 8x minus 8. Okay, that's all for me. Thank you.
So question 3, given cos 2x plus exponent y plus 1 over x is equals to ln 9x minus x plus 7 to the power of 6 minus y cubed. Find dy over dx using implicit differentiation. So first, we must equip both function with d over dx. Then we need to differentiate all the term one by one. So the first term is trigonometric function. We need to use these two formula to differentiate trigonometric function. So first, differentiate 2x, we will get 2. Then differentiation of cotangent, we will get negative cosecant square x. Then we copy the 2x, we will get negative 2 cosecant 2x. So the next term is exponent y plus 1 over x. It is a rational function, so we must use quotient rule. So the u is its numerator, which is exponent y plus 1, and the u prime is the u differentiation, which is exponent y plus 1 dy over dx. For the v, it is the denominator. For v prime, the differentiation of v, which is 1. Then we apply it with the formula, so x times exponent y plus 1 dy over dx minus exponent y plus 1 times 1 over x squared. And then we will get exponent x exponent y plus 1 dy over dx minus exponent y plus 1 over x squared. So the next term is ln 9x. So by using the formula here, we need to differentiate 9x, then we copy the 9x, then after we simplify it, we will get 1 over x. Next, negative x plus 7 to the power of 6. First, we need to differentiate the outer, so we will get negative 6. Then we minus the power 6, we will get 5. Then differentiate the inner, x plus 7, we will get 1. Then we simplify it, we will get negative 6x plus 7 to the power of 5. So the last term is negative y cubed. So first we move the 3 to the front, then we minus the power, so we will get negative 3y squared dy over dx. Then we will get negative cosecant square 2x plus exponent y plus 1 dy over dx minus exponent y plus 1 over x squared equals to 1 over x minus 6x plus 7 to the power of 5 minus 3y squared dy over dx. Then we eliminate the denominator, we multiply both sides with x squared, then we will get negative x squared cosecant square 2x plus exponent y plus 1 dy over dx minus exponent y plus 1 equals to x minus 6x squared x plus 7 to the power of 5 minus 3x squared y squared dy over dx. After that, we collect all the terms with dy at one side and factor out it. Then finally, we solve the dy over dx.
Okay, so now let's answer question 4. Question 4. Use linear approximation to estimate the value of ln 5 minus 2 times 2.09 plus 8 over 2.09 square. Correct to 4 decimal places. Alright, from this equation, we can conclude that x is equal to 2.09. So the function will be fx equal to ln 5 minus 2x plus 8 over x squared. Now, to find the x0, we need to choose between ln 5 minus 2 times 2.09 or 8 over 2.09 square. So I'm going to choose 8 over 2.09 square, which result in 1.83. So let's pick the closest number to 1.83. The closest number to 1.83 is 2. So how do we get 2? We get 2 by dividing 8 over 4. And 4 is also 2 square. So we can find x0 now. x0 is equal to, so let's find fx0 or f2 because x0 is f2. So input the 2 inside the equation, ln 5 minus 2 times 2 plus 8 over 2 square. The answer will be fx0 is equal to 2. So now let's find the derivative. Differentiate fx equal to ln 5 minus 2x plus 8 over x square. Let's transform 8 over x square to 8x to the power of negative 2. So now we have to differentiate ln 5 minus 2x. To differentiate ln 5 minus 2x, we need to differentiate the negative 2x because it is the only number that has a variable in it. And after we have done differentiating negative 2x, we will got negative 2. And just copy 5 minus 2x and put it below. So to differentiate 8x to the power of negative 2, just bring negative 2 to the front to multiply with 8. And then the power negative 2 needs to be subtracted with 1. So we will get negative 16 over x to the power of 3. So after we have done differentiating, we need to find f prime x naught. To find f prime x naught, we need to insert the x naught inside the derivative. So you will get f prime x naught equal to -4. And to complete this question, we will use the formula fx is estimated to be fx naught added with f prime x naught multiplied with x subtract x naught. So let's get the fx naught, which is -2, and then the f prime x naught, which is -4, and then the x, which is 2.09, subtracted with x naught, which is 2. Let's complete the bracket first. So 2.09 minus 2, we will get 0.09. 0.09 multiplied with -4, and we will get -9/25. And then finally 2 plus -9/25, and we will get the final answer. Fx is estimated to be 1.6400. That's all.
The final chapter of our video, which is the conclusion. Now the conclusion is differentiation helps us understand how quantities change. It's essential in math and real-world applications. And earlier work covered several core techniques for differentiation, which is product rule, quotient rule, and chain rule. And each technique is useful for specific types of function and problem-solving scenarios. You can master these rules is to solve complex calculus problems efficiently. And as a final part, the more you practice differentiation techniques, the more naturally they become part of your mathematical toolkit. And I just want to say thank you for everyone watching this video. Thank you for everyone for helping me with this assignment, and thank you, Miss B, for teaching us calculus. That's all from me. Thank you.